Hi, everybody. It's Professor Mitchell, continuing with Chapter 5. Today, we're looking at Section 5.3 on multiplying polynomials. In this section, we're going to multiply monomials, use the distributive property to multiply polynomials, and finally, multiply polynomials vertically. And again, throughout this chapter, we're working on SLOA, which is to perform mathematical operations on algebraic expressions. All right, so we start with multiplying monomials, which is actually a review of section 5.1. So I'll just quickly show you the examples here, and then I am going to switch over to the tablet and actually stay there. Because this whole PowerPoint is just examples. Everything I have to tell you about them, I'll do as we go along here. All right, so again, this is a review of section 5.1. To multiply two monomials, just use the rules for exponents. Negative 5.2 times 3 is negative 15.6. And then remember to multiply 2 powers of x, like x to the fourth times x to the fourth. You add the exponents. So in this case, you would get x to the 8th. All right, same kind of thing in letter B. We're going to start by multiplying the fractions. Negative 3/4 times 1/7 is negative 3 over 28. And again, using the product rule, y to the 7th times y to the 4th is y to the 11th. All right, and for the last example in this batch, we have x times 5x to the 4th times negative 6x to the 7th. 5 times negative 6 is negative 30. And then to multiply these powers of x, remember that there is an invisible power 1 on this x. So the new exponent will be 1 plus 4 plus 7, which is 12. All right, so next we come to multiplying a monomial and a polynomial. And to do that, we're just going to use the distributive property. All right, in letter A, we have negative 3a times 2a plus 7. So distributing negative 3a, we get negative 3a times 2a plus negative 3a times 7. Right, and you will likely get to a point where you won't need to show this much work. You may even already be at that point. All right, negative 3a times 2a is negative 6a squared. And then negative 3a times 7 is negative 21a. And instead of writing plus negative 21a, it's simpler to write minus 21a. Remember what we've talked about before, that when you distribute a term with a negative sign on it, it changes all the signs inside the parentheses. So that's going to happen again in letter B, right? We're distributing a negative x. And the pattern of the signs inside right now is plus, minus, plus, minus. So in my final answer, that pattern is going to be minus, plus, minus, plus. All right, so this time I think I'll skip that second step. So the new first term is going to be negative 6xy to the 3rd. The second term is going to be plus now. And x times x gives you x squared. So this is going to be 5x squared, y squared. Third term is going to be minus, and x times x squared is x cubed. So this term is going to be x minus x cubed y. And then finally, we have negative x times negative 5x to the third, which is positive 5x to the fourth. All right, and then the last example in this batch is 1/3 y squared times 9y squared minus 6y plus 1. So again, we're distributing the monomial that's outside. This time, I think I will write that second step because we have a fraction involved. So we have 1/3 y squared times 9y squared minus 1/3 y squared times 6y. Okay, and then the last term is times 1, so that one's easy. I can just write plus 1/3 y squared. All right, so now we have some fractions to multiply. I don't think I've ever said this to you before, but if I'm given the choice between adding, subtracting, multiplying, or dividing fractions, the easiest one of those things to do with fractions is to multiply them, right? Because you don't need common denominators. All right, so hopefully you're comfortable at least multiplying fractions and dividing them, right? Dividing them is really not very much more difficult, just the extra step at the beginning. Okay, 3 and 9 have a common factor 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And then 3 and 6 have a common factor 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So my final answer is going to be 3y to the fourth minus 2y cubed plus 1/3 y squared. All right. So now we are multiplying polynomials where both factors have more than one term. I'm going to show you another way to do this in the next section. But in the meantime, I do want to do it this way so we can still use the distributive property. I am going to color code this in the first example or two because I want to make it clear what I'm doing. All right, so I'm going to take this y minus 10 as if it was just a single term, and I'm going to distribute it here and here. Okay. So I'm going to have the y plus 11, but now each of those terms is going to be multiplied by y minus 10. See how that works? All right, and now I need to distribute again, right? I need to distribute a y here, and I need to distribute an 11 here. All right, so that is going to give me, I should be writing equal signs here. That's going to give me y squared minus 10y plus 11y minus 11 times 10, which is 110. So what often happens in this kind of problem is that you do get some like terms. In this case, we have negative 10y plus 11y. Since negative 10 plus 11 is positive 1, I can combine those terms into plus 1y, which we usually write as plus y. All right, so my final answer is y squared plus y minus 110. All right, next example. And as usual, please feel free to pause the video and try these first, and then come back and compare notes. So let's color code this one again. We have x plus 3/5 times x minus 2/5. I'm going to distribute the x plus 3/5. So I'll have my x minus 2/5, and then each of those terms is being multiplied by x plus 3/5. Oops. Right? Oh, and I'm leaving out the equal signs again. Okay. So now we'll distribute the x and distribute the negative 2/5. Notice that's a negative 2/5. So that is going to give me x squared plus 3/5 x minus 2/5 x. And then negative 2/5 times 3/5 is negative 6/25. Combining the like terms, since 3/5 minus 2/5 is positive 1/5, the final answer is x squared plus 1/5 x minus 6/25. All right, see how that works? Let's go to the next example. Oh, yes. All right. This is the square of 6x minus 7. So let me talk first about how not to do this. All right. You might think that this is, I'm going to pick green here. I really should pick red. Red is in stop. Don't do this. You might think the thing to do here is square the 6x and then square the negative 7 or something. Okay. Please, 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 whatever you do, don't do that. No, no, no. Okay. Because what we really should be doing is remembering that the square of 6x minus 7 means multiply 6x minus 7 by itself. Okay, so maybe this time I'll skip the color coding. We're going to distribute 6x minus 7. So that's going to give me 6x times 6x minus 7 minus 7 times 6x minus 7. Distributing the 6x, we get 36x squared minus 42x. Distributing the negative 7, we get another minus 42x, and then we get a plus 49. Notice that these two terms are exactly the same. We'll be talking about that more in the next section. In the meantime, negative 42x minus 42x gives you minus 84x. And this is my final answer. All right, next example. Now we have a binomial and a trinomial. Well, it works the same way. Distribute the binomial. So that's going to give me a set of three things. It's going to start with x squared times x plus 3. And then 5x times x plus 3. And then minus 8 times x plus 3. All right, and then performing each of those multiplications with the distributive property, you get x cubed plus 3x squared plus 5x squared plus 15x minus 8x minus 24. So now I believe there are two pairs of like terms. There's one here and one here. So my final answer is going to be x cubed plus 8x squared plus 7x minus 24. All right, and then the last example in this batch is another binomial times a trinomial. So I definitely want you to pause the video, try this one, come back and compare notes. This is one of my favorite examples right here. And when I do it in a face-to-face class, I always stop, wait for the class to do it, and then we go over it. All right, so I'm going to take your word for it that you've done that. This one is a lot of fun. as you hopefully know, we have x squared times x minus 7 plus 7x times x minus 7 plus 49 times x minus 7. Distributing the x squared, we get x cubed minus 7x squared. Distributing 7x, we get plus 7x squared minus 49x. Distributing 49, we get plus 49x minus 49 times 7, which is 343. Oh my gosh, look what happens. Not only do the x squared terms drop out, but so do the x terms. So amazingly, when I multiply this particular binomial by this particular trinomial, my answer is a binomial. So that's pretty surprising. We will talk in the next chapter, chapter 6, about why that happens. All right, but in the meantime, I want to end this section by talking about multiplying vertically. So as you saw in the last two examples, you might find it a little confusing. Multiplying, for example, a binomial and a trinomial using the method I just showed you. So what you can do as an alternative is set it up like you're multiplying two numbers. So what I like to do is put the longer polynomial on top and the shorter one on the bottom. And then it's just like you're multiplying two numbers, just like you're doing 824 times 45. When you do that multiplication, you start with the 5. So I'm going to start with minus 5. Minus 5 times minus 4 is plus 20. Minus 5 times 2x is minus 10x. Minus 5 times 8x squared is minus 40x squared. And then, just like you're multiplying numbers, when I go to the 4, I'm going to leave a space here. So 4x times minus 4 is minus 16x, and I'm going to write that here. Oh, maybe I should color code this. Okay, so let me start that again. Oh, darn it. Hold on, I'm sorry. Okay. Accidentally left my eraser on. Okay, want blue pen. 4x times minus 4 is minus 16x. 4x times 2x is 8x squared. See, by skipping that space on the right side, my like terms are lining up. 4x times 8x squared is 32x cubed. And then when you add those all together, you end up with 32x cubed. Negative 40 plus 8 is negative 32. That's an x squared. Negative 10 plus negative 16 is minus 26. And then just bring down the 20. All right. A lot of people think that that system makes it easier to keep track of everything. It's not as confusing. And it's especially great when you're multiplying two trinomials. I would not want to do this using the distributive property. All right, so 3x squared minus x plus 2 times x squared plus 2x plus 1. All right, starting with the 1, that's just going to copy the top polynomial. And then skip a space, multiply by 2x. 2x times 2 is 4x. 2x times minus x is minus 2x squared. 2x times 3x squared is 6x cubed. And now I go to the x squared. I skip another space. X squared times 2 is 2x squared. X squared times minus x is minus x cubed. And x squared times 3x squared is 3x to the fourth. Add those all together. Notice the like terms are lining up again. And my final answer is 3x to the fourth plus 5x cubed. Could just cancel those two, plus 3x squared plus 3x plus 2. All right, so that's how you multiply two polynomials. In the next section, we'll look at a few shortcuts and special patterns. Until then, have a great day, and we'll see you next time.